Well, hello friends. Today we're going to do some kernel work, because we haven't done that for a while. Just been doing all this GUI stuff. So what I have in mind today is we're going to do munmap, but partial, so that let's look at a process's memory maps. Come on, system monitor. So let's grab. I guess we can grab the system monitor itself, and we'll look at these memory maps here, or memory mappings that he has. Make it a little bit bigger, and I screwed that up. So you can see these mappings that some of them are large, like here's a font, and it will be, we should be able to unmap like a partial nmap basically, and that should just keep the original mapping but make it smaller. And then if you munmap like a hole in the middle of a mapping, then we should create two new mappings, one for each side of that hole that we just created. Yeah. So basically we need to do some region splitting, and I'm not going to do any kind of merging right now, and we're just going to do naive splitting. But it will still be a very useful feature, I think. So I guess we can start by making a little test program for this. So what do we want to do? Like we'll just call it a map test. Not very creative, but whatever. A map test. And of course we'll include sysmman and std.io. Okay, and then just the usual stuff. Okay, and then let's make a mapping. So let's do, let me grab my usual toolkit, at least the types, or at least the assertions. Okay, so U8 data, and then we'll map it anywhere. And then we want how about we want 1 megabyte, and we want it to be prot read, prot write, prot exec. So anything goes. Flags should be map anonymous. Having a few more days of summer here, so like it's super hot today, and I feel some kind of allergic reactions going on. It's a little stupid. And I think for file descriptor, if we just pass, I always forget how this works. Oh, right, if we pass anonymous, then it doesn't look at the file descriptor. Right. That makes sense. And offset, so we can just pass zeros here, actually. Okay, and then we'll assert that data is not map failed. Okay. And then what we want to do is we want to cut a hole in this guy. So we'll say we'll do int rc is munmap data plus let's cut the hole 1 page into it. Why not? Actually, we can type page size, and we'll cut a 1-page hole there. Right, so then we should get RC is 0, and then if we, I guess we're going to want to crash this program so that we can get the crash dump. So I'll show you what happens now. So if RC, we can do this actually. Because we should get an error from munmap. Because the way munmap currently works is that we look for an mapping or a region rather with exactly this starting address and exactly this size, and we're not going to find that. Why don't you like me? Oh, U8 is not. Okay, I thought that that would be implied. I guess not. It's not going to find that, so this thing should fail here. It should say like E inval maybe? I'm not exactly, I don't recall what the error is. We'll find out very soon when we type mmap test here. Invalid argument. Right. And then right. So I think we should just crash in all the cases, because crashing means that we are going to get a region dump from the kernel on exit. So meanwhile, oops, let me show you what the syscall munmap looks like. So here it is, and we call region from range, and then we pass in the address and the size. Basically, like I was saying, we just look for a region with exactly the starting address and exactly the size, and there's no such fit. Let's just see that we get the region dump when we crash. Map test. Right, so here's our region dump. This is the 1 megabyte mapping. It's still intact, as you can see. So that's not working right. So let's have a look at this. How do we want this to work? So I guess if we can find a whole region like this, then it's probably fine to just deallocate the whole thing. So we can say if there is such a region, then we can do that. Why would this fail? Deallocate region. But we just found it. How would that even ever happen? I don't understand. That doesn't make any sense. Okay, let's put one of these here. Now it won't make any sense anymore. Or no, we don't need that. What the hell am I thinking? This is not going to fail. So, full success. Assert. This should always fail. I mean, always succeed. Okay, so actually we can even do it this way. Okay, so we're here. And now we need to see if we can hit any region that has this address inside it. So let's see. I guess if we'll make a helper for this. So region containing virtual address C32. Maybe we can make a range object for this actually. How does this work again? Virtual address and size. But you don't like me because? Oh. I guess that's fine too. And then it would be nice if we had this API just take a range instead. And then we can do the same here. Then let's just tweak this API here, or actually let's make a wrapper for it, because I guess this is used in a few places. Not terribly many places actually. Okay, let's do const range here instead. We can do that. I just want to fix this up. Const range. Because I didn't have the range class when I wrote this code, so that's why. Okay, and then range base. Okay, that's pretty good. And we can also do region containing in much the same way. So this will give us a region. If there is a region that contains, like wholly contains this range, then we'll return that region. So can we get the range from a region? No, okay. Region contains, exists. How cool is that? I guess I will say range base and region contains range dot end. What is range end? It's base offset of size. So the end is, I guess the end is like the next region's starting address. Does that make sense? It's the offset of size. Yeah, so you have to be less than end. Okay. I guess that makes sense to call that the end, because it's not like the last valid address, it's the end of the region. Okay, well, it's just something to keep in mind here. Okay, and then we forgot to add the prototype for that. So region containing. Now the region, let me open here actually. It's quite warm, as I mentioned. Yeah, so the region data structure, this is how we store our memory regions at the moment. This should definitely needs to be replaced by something more efficient than a vector at some point, but it works for now, and we can live with linear access performance at the moment. I mean, if you listen to my commute talks, then that's something that comes up every now and then, that I really think that it's better to build with simple building blocks and try to get as far as possible. Just build it in a generic enough way that you can replace those building blocks without disturbing the greater program too much, if that makes sense. So that's sort of what I'm trying to do here. Like I make APIs to search for ranges and stuff instead of going directly for the mRegions vector, like, because I know that one day I'm going to want to put a red-black tree or something here, but it's not urgent. We have bigger problems than this right now. So this should really be like that. To contain this regions dot end. Can we do regions and offset? No, it's not gonna work. Okay, well, we should have region contains range, actually. That would be the right API to have, so let's just add that. Contains. Ooh, contains. And then return mRange contains range. And that was already a thing. See? So, good thing I was thinking in the generic way here instead of trying to solve it manually here, right? That's a perfect example of what I was just trying to get across. Like go for the slightly higher level, like explain in English what you're trying to achieve type programming. Okay, so totally good. Then we can just get rid of this. We'll put a range here. We'll say range, virtual address, U32 adder, and size. I got some red down here. What's going on? Oh, whoopsie. Well, here's an unrelated thing. It's definitely a bug. I have to do dot characters on that one. Wow. Should have spotted that in code review, actually. I reviewed this a few days ago. That was a mistake. Anyways, we'll get there. Let me just make a note to fix that, actually. Let me get my G note. Fix me. Don't forget, bro. Sys real path passes a string to printf. All right. So let's see if we can just build this. Okay, so if we find this region, what do we want to do? I guess we want to create a region for it and a range after, so, or range before and range after. So let's make those first. You can call them left and right. Or, yeah, left and right is kind of nice. So that would be range, no, region, base. Wait, do I have some kind of splicing thing here already? Range, carve. Yeah, I wrote this code. So you call carve, and then you pass in the range that you're taking out, and it gives you the left and the right in a little vector. Which is kind of hilariously awkward now that I think about it. We could just return them in a some kind of pair struct or something, I don't know. But a vector is fine too. Okay. So, parts. Region, or yeah, region. We need the region range carve out the range. So we have to have a way to get the range of a region. Did I ever mention what a range is? So range is just a base address and a size. So it represents a range of virtual memory, basically. A virtual address space range. So let's go and... Because region has a range internally. That's just where he starts and how big he is. It's this guy. But we're not actually exposing it to the outside world, which we totally could. We just had these two instead. But I guess because we never needed the range for anything until now. So, boom. Okay. So right, back in munmap. We do region, range, carve. Oh, that's non-const. Okay, right. Yeah. Let's grab it out. So old region range, and maybe we'll call this one range to unmap, just to make it a bit more clear what's going on. Region range. Remaining parts ranges after unmap. range, carve, range to unmap. Okay, and this can give us 1 or 2, right? Yeah, it might give us 0 or 1 or 2. It shouldn't give us 0 though, because then we should have been here. So we'll say remaining ranges after a map size is equal to, oh, say it's not empty. Wait, vector is null? Oh, okay, let's just ignore that. That was for some helper that I needed that, never mind. Because what we want to do now, we want to take those 2 ranges and we want them to have the same physical pages as they did before. So we got to copy those over from the existing region. So we got to make 2 new regions here. Okay, so call this make replacement region, and we'll say const range, new range. Let's see, yeah. Okay, and new region is allocate region. At the new range base, new range size. I guess we'll just take whatever name this region had. We will just, can rename this to old region actually. The name will carry over. Okay, and then I guess the prot is going to be the old region prot. Can we get that? No? Damn, okay, so we got to compute the prot value somehow. And commit's going to be false. And that means that we're not going to allocate physical pages. I'm thinking that allocate region, we're probably going to be better off with something different here. Prot to region access flags. Because we have region okay, we'll just compute it. Is writable. Okay, we can do it like that. Yeah, that's really silly, and okay, so yeah, so this means we don't allocate physical pages because we're going to use the existing physical pages from the old region. So we'll say new region. Oh shit, how's this going to work? The region points to a VM object. How do I get to that? To VMO, okay. And then the VMO needs to have the physical pages. Right. Right. So physical pages, I is old region, VMO, physical pages. Let's see, we just call it old base plus I. Okay. And then we'll make a loop where we do new region, VMO, or page count, I guess that's fine. And all we need now is to compute the starting page offset in the old region for this region, which is the distance from the base of the new range to the base of the old region, divided by page size. Offset, new range, offset, region is new range, dot base, dot get, minus old region, range, base, get. Maybe we can actually minus like this, does that work? That works, that's kind of neat. Okay, because then the old base, well, that sounds, I mean, that's such a shit name, but hold on. It's first physical page in new region of new region in old region. Okay, and then that's the new range offset. Actually, yeah, since this is an offset, then we should, it shouldn't be addresses, it should be like an actual offset. So we'll use the size t type for that. And we can assert that the new range dot base is always greater than or equal to old region ranged base, because otherwise something is very off. And we divide it by page size. So, goddamn, that's a long name. Page offset, is that a better name? It's not super better. Anyways, so we should use this. So make replacement region. We'll do for auto new range in remaining ranges after unmap. Make replacement region new range. And then finally deallocate region old region and return 0. Otherwise, return e-inval. That was a lot of code. Actually, it wasn't that much code. It was more like some code I haven't been writing for a while. We don't need that. Good for you. Yeah. Okay, let's try this out and see what happens. Okay, so we crash in the kernel. Well, that's not very good. 1D, 5DF. Crashing in munmap. Oof. After carve. Before allocate region. So between carve and allocate region. Let's just add a bunch of assertions here just to be on the safe side. New region. I mean, that should always succeed, but still. Okay, let's see, debug. Let's do some debug output. We'll have regions remaining. Oh, and we don't have a way to log those. We should do that. So no, return stream. Can do. Oh no, hold on. Range. Maybe something like that. It's kind of cool. And then let's just get act string here. And let's say base get and value and get -1. First of new region and old region. Maybe that one is all kinds of screwed. Oh, why didn't that work? Oh, I guess I have to cast it to something. Okay, I just want to see what happens. Assertion failed. New region. So this actually fails. Okay, so allocate region gets an invalid range. Well, why is that? munmap will have 2 regions remaining. Okay. Placement region range. Why would that not be valid? Oh, we're trying to allocate the range. Oh shit, it's not gonna work. Yeah, right, so I was right with my hunch that we couldn't reuse this code because we don't want to allocate a new range. We already have the range in mind. So we do placement region. maybe even allocate split region. We can just take a range and actually we can also take the source region. Then we don't need that, and instead we can just pass our access flags directly. We're never going to do that. And this one, we shouldn't do this, I think. We should wait, not map the region into the page tables until we're done with everything. So we'll do that after we deallocate the original region. Yeah. Allocate split region, right. Well, where the hell are these coming from then? M-access, right. Oh, I guess it's source region dot access source region dot name. Okay. I'll just have access const return and access. I guess we never thought to expose this before either. So the access is just the read, write, execute bits. And it seems like we have to, let's return that as an unsigned actually. Because it's not one of these values, it's a mask. So, you know. All right. And maybe we'll call this a split region instead. Yeah, let's do that. Split region. Or allocate split region. Allocate split region has slightly different semantics than the other allocate region calls, but I guess that's just something that you have to be aware of when you're using it, because it's not like, you don't use it like the other ones anyway. It's not like a general allocator, so. It's for a specific purpose. Okay. And then who was the jerk who was using this? I guess this guy right here. So here instead we'll say allocate split region, old region, and new range. Right. And then we can get rid of this gunk. Okay. Could not bind, right? Because it was a pointer, not a reference. Okay, so we've crashed, and look at that. We have two regions here where there used to be one. This one is 1 page, or 4 kilobytes. And then there's a hold between 2B0 and up until 2C0. Very cool. And then I guess we can try to write something into the hole just to see that it actually crashes from that, because otherwise, I think we're missing something here. We're not remapping the regions, so it would be funny to test this. So let's see. Should crash putter. Crash putter. Or data plus page size. dash putter is X. No, let's put some cooler letter, like K. All right. Bye. All right. Failed when writing to this address. That is very cool. All right, so that would fail. And let's do a save putter. Save putter is, I guess, A is for safe. Save. We can also have a also save putter. This one can be a C. See, now we're spelling out AC. Data plus page size times 2. Huh. I don't have my car this week, which is a bit unusual because it means I can't do the commute talks. So I'm riding the train. That's okay too. It's nice to ride the train. Do a little hacking on the train. I mean, there's only so much you can do in a 35-minute train ride, but still, I do enjoy it. All right. Yeah, so this went to heck because we didn't remap everything correctly. So after we deallocate the old region, then what we want to do is we want to map the new, so we'll say map into this. And we want to do this for all of the new regions that we made. So it's a bit smelly, we got to put those somewhere. I guess we can just put them in a little vector. We'll do like this. Return new region. And then we will have a vector of this can just actually can just be a vector of region star 2 new regions. You can do unchecked append because unchecked append is it's like regular append, except you know that there is enough capacity in the vector to accommodate it, so that then it can just skip the like, do I need to dynamically grow the vector checks. So it's slightly less code when you know that there's capacity. And we know that here because we allocate two entries of inline capacity, which is the maximum number of new regions. Anyways. And then here we'll just do for auto new region, just like that. Regions. Let's write these out with curly braces because it's, I don't know, for some kind of emphasis, I guess. Okay, so we deallocate the old one and remap the 2 new ones. And hopefully that will do the trick. Now we should crash in the not safe putter, which would be 2B whatever, which is exactly where we're crashing. How cool is that? All right. So I think we have just successfully implemented munmap splitting. Nice. Nice. I feel like I have a bug about this somewhere, so let me look that up. Let's also do a patch review, by the way. that's not working out. GitHub. Munmap, maybe? Partial and multiple regions. Should be able to both unmap part of an existing region, possibly turning it into 2 regions with a hole in the middle. Should also be able to unmap multiple regions if the specified range spans multiple regions. Well, this one we haven't done, and I'm not going to do that one right now, but at least I'm going to reference the bug number. So let's look at our patch here. So here's a little header sorting, which we'll tolerate. And then there's the new helper allocate split region, which gives us, a new region from a source region that has the same name and access bits as the source region, but a different range. Okay, and then region from range, we just changed the API of this guy so that he takes a range instead of a address and size. It's just a little ergonomics improvement. And we added this region containing helper to give us the region for a given range. Here we are just using the new region from range API that takes a range. Let's see, region from range. We can actually tidy that up a little bit because we don't need a temporary here. We can just write it this way. I think that's fine. Still looks a little awkward actually, but it's nah, it's okay. And yeah, here's just more of that. Or that's the one that I changed actually. And then now here's the new munmap function. So let's see. Munmap. So this one we can rename to whole region. Okay. So if we find a whole region, then we deallocate the whole thing and return success. That's awesome. Otherwise, if we find a region that contains this one, maybe we should have a fix me here. Fix me. We should also support munmap across multiple regions. I can put that bug number here. 175. And I should get rid of all the debug output because we don't need that anymore. It's just noise. Okay, so what does this do? So if we find a region that contains the range that we want to unmap, then we grab that range of the old region and carve out the whole and see what remaining ranges we have after the unmap. We assert that we have some, and we assert that we do have an old region, although this is a little superfluous because we wouldn't be here. So, and then this one is not going to fail. So actually we could do it this way. Split region. We'll just let this one always succeed. And then we'll do it that way and that way. And then these will be dots, which is very nice. Dots, dots, dots. And then it can return. Just do that. Copy constructor. Oh, I don't want that. I want to return a range amp. Wait. Region amp. Sorry. Okay, here we go. Right. So we carve that out, and then we make one or two replacement regions for these new ranges. So this is just a helper for that, making a replacement. And what that does is that we allocate a split region from the old region with the new range, and then we compute where in the old region is the start of the new region, and then we just copy over the physical pages one by one. And then we return it. And then down here, we add those to a vector of new regions. Then we deallocate the old region and map the new regions. Map region means that we add them to the CPU page table. So this is where they actually take effect. And then we return 0 for success. And then here, yeah, just fail. Okay, and then this is just the region from range API. And protect. And protect is going to need some code like this too. I'll probably do some code sharing, but I'm not going to implement that right now, but it's something to do. Okay, here's the header for allocate split region. Here's region containing, new API for region from range. Okay, range allocator, we add a log stream operator for ranges. So let's do that one separately. I'll just say kernel add log stream operator for range. Okay. And then region got some comfortable APIs here. Oh, we can get rid of some unrelated Windows Server changes that I don't want to get in here. So region, we just add some convenience getters for range, access, and contains. So we can do those separately as well. And oh, look at that. We're going to go past 4,000 here. That's very nice. Kernel add some convenient helper getters to region. Getters for the underlying range, access bits, and also a wrapper or contains range, just forwards. Okay. Let's push this just to get the cool number. Ah, very nice. Congratulations, everybody. 4,000 commits. God damn. See, I told people that I would get there before the 1-year anniversary. And we did. It's awesome. Okay, let's do some more. Okay, so kernel. Support partial munmap. You can now munmap a part of a region. The kernel will then create 1 or 2 new regions around the whole and remap them using the same physical pages as before. This is part of a fix partially. goes towards pixel. What was it, 175? Yeah, 175. On the way. We don't yet do munmap across multiple mappings. Anyways, still is pretty cool. Okay. So just gonna build the whole thing and see that we didn't break the world. Oh yeah, that's pretty awesome. Good to do some kernel work. It's been so much GUI this week. I mean, I shouldn't complain because I love the GUI programming and it's fun and it feels productive, but it's also good to go and give the kernel some love. Okay, well, we're almost at the end, so I guess we're just gonna see the little demo one more time. And yeah, look at that. We are indeed, we've split it into 2 regions and we are failing at that address that is 2 pages in. Yeah, exactly. Cool. Very, very cool. Okay, so I think that's going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out, while we continue to work on this operating system. Hope you saw something interesting, and I will see you next time. Bye.